Hello, I welcome you all. The problem reads that the box has a mass m and slides down the smooth chute having the shape of a parabola. If it has an initial velocity of v naught at the origin, determine the velocity is a function of x. Also, what is the normal force on the box and the tangential acceleration as a function of x. This problem is coming from the Engineering Mechanics and Dynamics, our 14th edition by R.C. Benam. So we are being asked here to determine the velocity as a function of x, the normal force as a function of x, as well as the tangential acceleration as a function of x. Alright, so let's draw the free body diagram. Of course, we do have the weight. Let's say that is our weight acting through the center of gravity. Yeah, like so. Right, and let's say we do have the normal force. They are like so. Alright. Of course, this is smooth, and by this we mean if this chute is smooth, it means no friction between the box and the surface. Right, so we are going to have components of this particular weight. We'll have one component in this direction like so, and we'll have another component in this direction like so. Okay, then we need the angle. So let's say this is the angle. Hold on. So we have this here is the coordinate, tangential coordinate. All right, and then we have this. Of course, we do have another coordinate there that I'm going to call the normal. Okay, coordinate or axis. So the angle that we are interested in is this one here. This is theta. So if this is theta, this becomes 90 minus theta, then this becomes theta, right? So that is the same angle here. This is theta, right? Okay, this is theta. So let me label this. So we said this is W, this therefore is W cos theta, this is W sine theta. Okay, and this is our normal force. This is the t coordinate. This is the n coordinate. We have the kinetic diagram showing the motion, direction of motion. There we go like so. There we go like so. So we have MAT, then this one is MAN. Alright, so for the angle itself, we need to find the first derivative. We also have what is called along this direction here. Let me call this as our rho, which is equal to r, the radius of curvature. Alright, so we need to calculate this. It doesn't look straight, but it's fine. And look very straight. Let me redraw it. Sorry. I prefer it straight. but it's no big deal whether it's straight or not. Just my preference. You don't have to do this. Okay, maybe something like this. So let me call this as my rho, which is the radius of curvature. So we need to find this. So my y is equal to minus 0.5 x squared. Therefore, my y prime is just going to be equal to minus 0.5 by 2 x, which is just equal to minus x, right? Then y prime, y double prime will just be equal to minus 1. Then we know that rho itself is just equal to 1 plus y prime squared to the power 3 over 2 or 1.5 divided by y double prime, and this just becomes a 1 plus minus x squared divided by all this raised to the power 1.5 divided by minus 1 absolute value or the modulus. So rho itself is just going to be equal to 1 plus x squared, okay, to the power 1.5 divided by 1, which just becomes this. All right, so let's now find the angle. So we know that tan theta is just going to be equal to y prime, and this is equal to minus x, which is just also equal to minus x over 1. So we can write this in terms of a triangle, since we want to represent everything in terms of x. So we can say we have this triangle like this, right angle triangle. Okay, that's representing the angles. We have theta there. That minus will just show that the angle is just showing that the angle is clockwise. So we do have this part we've seen here. Tan theta is always the change of y, or the change in the vertical component divided by the horizontal component. So the y here is x, and this is 1, and therefore this becomes x squared plus 1, right? So therefore from this we know that our sine theta is equal to x divided by, this is equal to x divided by root of x squared plus 1, and cos theta is equal to 1 divided by x squared plus 1. Okay, all right, so with this information, let's apply the equation of motion in one direction with the summation of forces in the y, in the t. This is just equal to mat going in this direction in our reference positive. Okay, so this just becomes w sine theta is equal to mat, and therefore our at is just equal to w sine theta divided by m, which is just equal to mg sine theta divided by m. So this and this can go, and then this just becomes equal to, we know what sine theta is, it is this one here. We can replace this, so this just becomes gx divided by square root of x squared plus 1. Okay, so our acceleration as a function of x is just gx divided by root of x squared plus 1. Okay, right. So this is about it. Um, right. So having said that, let's now find the velocity. So use this equation a ds is equal to v dv. This equation comes from the kinematic equations, v equal to ds dt and a equal to dv dt. All right. So again here, rho is not constant, it keeps on changing. So our integration constants here can either be y, vertical component, or x. But since they want velocity to be expressed in terms of as a function of x, therefore we are going to use the x, the change in x as or we're going to write ds in terms of dx. Okay. So to do so, again, we need to just relate this the right angle triangle like so. So we have this as our ds, we have that as our dx, and this one as our dy. Okay, and this is the angle. So this one is our dx, this is our dy, this is our ds. So we know that if we are to relate this, we know that sine no, I need cos. So we know that cos theta is just equal to dx over ds, and therefore making ds subject to the formula, this just becomes equal to dx over cos theta. And let's remember, we know what cos theta is. So replacing this, replacing it there, we're going to have this relationship. We have this relationship. So this, and also replacing this cos theta here, which is equal to 1 divided by root of x squared plus 1. We need to replace this also here. So we have the following. So let's write what we have. So we are going to have 80 that we want to replace, and then our ds just becomes dx divided by cos theta is just 1 divided by root of x squared plus 1. But this is as good as this going up, so we can write this instead of like this, we write it as this root goes on top like so, x squared plus 1, because it was underneath, then we have our dx, then this is just equal to v dv, right? Seeing what we've done, right? Of course you have seen. So let's integrate this. They told us already that our initial velocity is v naught, therefore here we'll have v naught to v. Then this side, our dx here, we are assuming this point of course is our reference, that's our reference, which is 0, 0. So this will be from 0 to x, any value of x. So let's replace 80. We know that our 80 is just equal to, we calculated 80 somewhere, there it is equal to gx divided by root of x squared plus 1. So let's replace it in there. Then we are going to have integral from 0 to x, gx, okay, divided by root of x squared plus 1, okay, times root of x squared plus 1, okay, dx. Then this v naught to v, then v dv. So of course this and this goes, and once it goes, then this just becomes gx squared divided by 2, and then is equal to v squared over 2, evaluating from v naught to v. Okay, which just becomes, if we evaluated this, just becomes this side minus v naught squared divided by 2. So therefore, our v squared will just be equal to 2 goes up there, they cancel, so all this goes, all this it goes, and then we have v squared will just be equal to v naught squared plus gx squared. Therefore, our v will just be equal to square root of v naught squared plus gx squared. So that's our v. We found v in terms of x. So let's apply the summation of forces in the n direction. So say summation of forces in the n, going down being our reference, and this is just equal to MAN, where our AN is just equal to v squared divided by rho. Right. What do we have in that direction? We have W cos theta, okay, minus N is equal to M v squared divided by rho. We want to find N, so our N will just be equal to, our N will be equal to M, open brackets, G, cos theta, okay, and then minus v squared divided by rho. So we know what cos theta is and what rho is. We know that our rho is equal to, what is our rho? Our rho is equal to 1 plus x squared to the power, so it's 1 plus x squared to the power 1.5. all right, and cos theta is equal to 1 divided by 1 plus x squared to the power 0.5. Therefore, our n, which is the normal force, just becomes equal to, our n, which is the normal force, just becomes equal to, this is just equal to, we have m there, okay, then I factor out my g. My cos is this one here, which is just 1 plus x squared, okay, to the power 0.5. all right, and then this is minus our v squared. Since this one, once it is squared, we just remain with v naught squared plus gx squared, then divided by our rho, and rho is just 1 plus x squared to the power 1.5. Okay, there we go. So this is our final solution. I want to write all of them to have the same formatting. My G also, I will write it like my A, I will write it as 1 plus x squared to the power 0.5. Alright, and also this one, I'm going to write it in the same format again. There is nothing wrong. This is just my preference. Doesn't mean you have to write like this. This is my preference. Okay. Okay, this to the power 0.5. Okay, I guess we are done. Let me just outline the solutions. So I have my acceleration there. My acceleration, and this acceleration is in terms of x, and then we do have my velocity also. It is in terms of x. Okay, and we do have the normal force. Okay, and it is in terms of x. Alright, I guess this is really about it. And I hope this particular video was helpful. And if it was, give me a thumbs up, like my video, continue subscribing and sharing my channel. Bye bye, and I'll see you in my next screencast.